This is our assignment number 6, and in this assignment you can see the problem statement. Check the mode of processor, real mode or protected mode, then read Gdtr, Idtr and Idtr and display the same content on the screen. So Gdtr and Idtr is the 48-bit register in the size, and Tr and Idtr is a 16-bit register in size, and MSW means the machine status word. It is a 32-bit in size. So they hold 32-bit base address and 16-bit limit field. So output format should be base address colon limit. So Gdtr and Idtr is a 48-bit register, and Tr and Idtr is a 16-bit register. MSW means a machine status word is a 32-bit register. So what is the algorithm? You can see the algorithm here. To check operating mode of processor, we can check protected mode bit or protection enable bit of control word register CR0. CR0 register we are using as a machine status word. In a CR0 register, basically it is a control register 0, and we have in 8086 processor 4 control registers: CR0, CR1, CR2 and CR3. And CR0 register we are using as a machine status word, so that's why we are calling that register as a machine status word register. So starting 16-bit basically working as a machine status word. And in the CR0 register, least significant bit, that is the PE bit, protection enable bit. So by using a protection enable bit, we can check your processor is in a protected mode or in a real mode. If your PE bit is set to 1, in that case your processor is in a protected mode. If your PE bit is set to 0, in that case your processor is in a real mode. So by using a PE bit, we can check your processor is in a protected mode or in a real mode. After checking your processor in a protected mode, you will display the content of Gdtr, Idtr, LDTR and TR on your output screen. So CR0 is nothing but the machine status word. So read content of MSW by using a store machine status word instruction. So store machine status word and load machine status word. So these two instruction is the privileged instruction we are using for accessing the control register, debug register, test register, etc. So these are the privileged instruction, means without checking a privilege level we cannot use this instruction. And check 0th bit by using a ROR, shift R or BT instruction, means you can check this thing by using a rotate right, shift right or bit test instruction. If carry is generated, means if your PE bit is set to 1, in that case your processor is in a protected mode. So by using a BT bit, means bit test instruction, or a shift right instruction or a rotate right instruction, we can check this thing your processor is in a protected mode or is in a real mode. Then display your content accordingly. So take variable to hold all registered content of required size. The storage means in a BSS section we will reserve the memory for Gdtr and Idtr as a 2 word, because it is a 48-bit register. So 1 word and 1 double word and 1 word. So double word is a 32-bit register and 1 word is a 16-bit register. So according to that we will reserve memory for Gdtr and Idtr. And TR, MSW, these are the 16-bit registers. So we will reserve 1 word memory for these things. Then store register content by using store instruction like sggt store Gdtr, means a global descriptor table register. So global descriptor table register, for this thing, for accessing the register we will use a sggt, means store global descriptor table instruction. And let the content of Gdtr, here you can see the content from 1 to 8 and ABCD. So ABCD is the limit field and 1 to 8 is the base field. So this content will store into memory like that. So to display first point to last byte, take content and convert and display. So this thing we will perform into our code section. So check operating mode of processor by reading a MSW, means a machine status word. Store machine status word EX, means whatever accumulator content here, you will save that content by using a store machine status word instruction. Then move control word comma EX. So accumulator value you will move into control word memory location. Then you will check that content by 1 using a rotate right instruction. If it is 1, in that case carry is generated, so your processor is in a protected mode. If it is 0, means carry is not generated, in that case you can see your processor is in a real mode. Then display real mode content or real mode message, means if it is not carry is not generated, in that case you will display the message your processor is in a real mode, and according to that you will display the content on your output screen. But if your carry is generated, in that case you will display the message your processor is in a protected mode, and according to that you will display your content on your output screen, means protected mode content on your output screen. So display registered content. So first we have to store the Gdtr, Idtr, LDTR and TR and MSW content by using our store instruction. So here you can see the store instruction SGT, SLDT, SIDT, STR and SMSW. So this is the store instruction, and load instruction again we are using for accessing these register, because these are the privilege instruction we have seen in a third unit. Some instruction are the privilege instruction and we cannot use this instruction without checking the privilege checking, because by using a privilege instruction or privilege checking, we will provide the protection for the 80386 processor, because this is a special feature of your 80386 processor. So these are the privilege instruction we can see. So store the content of Gdtr, Idtr, LDTR, TR and MSW by using a store instruction. Then display the content of Gdt message and Gdt message length. Then move bx, Gdt plus 4. This is the important thing. Gdt plus 4, Gdt plus 2 and colon then Gdt. So this is the format. By using this format, we will display the content on the output screen, and this is the important thing, because in this experiment, this is the important question: how you display the content on your output screen, and what are the instruction, means Gdt plus 4. So this instruction basically, why you are using this instruction Gdt plus 4 and Gdt plus 2 and Gdt, because your Gdtr is a 48-bit field, and 48-bit means 6 byte, and by using a Gdt plus 4 means last 2 byte first you are printing by using a Gdt plus 4, then next 2 byte you are printing by using a Gdt plus 2, then you will print colon, and after that you are printing the last means limit field you are printing by using a Gdt instruction. So this is the important thing, means how you display the content of Gdtr on your output screen. So by using these instructions, first last 2 byte we will print by using a Gdt plus 4 instruction. After that Gdt plus 2 means next 2 byte we will print out. Then after that colon we will print, and last limit we will print by using a Gdt instruction. So by using this thing we will display the content of your Gdtr, Idtr, LDTR.